Okay, for our last example of set partitions, we are going to show that A, script A, which is this collection of sets, is a partition of the entire real line. So let's remind ourselves what this means. N is just an integer, and for every integer we have a set, which is the interval, from n to n plus 1. So for example, from, let me just write a few of them down. For n equals -3, we would have -3 to -2 with a square bracket there. N equals -2, we'd go from -2 to -1, like that. So you've got an infinite number of intervals. And we need to prove that this collection of sets is a partition of the entire real line. Well, for starters, we just want to show that they're all disjoint sets, and that's pretty trivial. The number, I'm sorry, not disjoint, but non-empty sets. The number n plus 1 is contained inside this interval, which is one of the sets, for every single value of n. So when n is a 0, we have 0 is contained in 0, 1. So every single one of these has at least one element in it, so it's not empty. So therefore, script A is a collection of non-empty sets. Now, are they pairwise disjoint? Well, probably easy to see that they are, but proving it's a little bit tougher. I wanted to save some room here, so I usually say to the contrary when I'm going to do a proof by contradiction. But this acronym means for the sake of contradiction, for the sake of reaching a contradiction. Suppose that x, some number x, is an element of two of these sets. Okay, so we'll say m to m plus 1 intersected with n to n plus 1. Okay, so to the contrary, we're supposing or assuming that there is a number that's in two different sets. Now, I need to make sure that these are clearly different. We'll say where m is strictly less than n. We could have done it the other way around, but the proof would be the same. N is less than m, for example. Okay, well, what does that mean? By definition, this means x is in both of those sets. Right? So this means x is in this set and x is in this set. Or we could just say this means that x is in between. That's what it means for x to be in this set. It means it's between m and m plus 1. And it could equal m plus 1, but it can't equal the left endpoint m. And x is in between n and n plus 1. With the same inequalities, strict on the left and less than or equal on the right. Well, notice that we have hints. X is less than or equal to m plus 1 from this right here. But m less than n, what's another way of saying that if we're talking about integers? That means that m is less than or equal, let me put m plus 1 less than or equal to n. Think about that. We're just talking about integers. So if n is 10 and m is less than that, then, for example, 9 is less than 10. 9 plus 1 is less than or equal to 10. Correct? Okay. So this means that m plus 1 is less than or equal to n which is less than x because of this. So we use this fact and just these two facts, and we reach a contradiction. How could you possibly have a number in between x and x? These are two different integers. This one is n is at least 1 bigger than m. So x, actually you could really see the contradiction if we removed this part. X less than or equal to n, which is less than x. That means x is less than x. That's a contradiction. So I'll say that, or x is less than x. A contradiction. And that contradiction proves that our, for the sake of contradiction, suppose this is false. Therefore, if I had room, I would say this implies that script A is a pairwise disjoint collection of sets. So we just proved that. Now we have to prove that A covers R. Remember, that means that the union of all of the sets in A is equal to R. And as we mentioned earlier, since all of these sets are subsets of R, we know the union of all of them is a subset of R already. So we need to show that, I'm just going to write it really small, R is a subset of the union of the AIs, where I is all the integers. So that's what we're going to do now. So we arbitrarily choose an x, let x be an element of R. That's how we start, and then we show that x is also in the set on the right-hand side. All right, x is an element of R. Let's see, is it okay if I reuse n or m? Let n be an integer, so let me just say let n in the set of integers be such that, st is such that n is strictly less than x. Okay, thus x is an element of n to n plus 1. Let's make sure that's right. N is an integer. It's an integer that is strictly less than x. And I'm missing one word. I want it to be the largest integer less than x. So let n be the largest integer such that n is less than x. So these 3 words go, or 4 words, go right there. X is a real number. Let n be an integer. Let n be the largest integer such that n is less than x. That means that x would be inside this interval right here. And I can finish this by saying that is a subset. It's one of the elements in script A. So if it's in one of the elements, one of the sets in script A, it's in the union of all of the AIs. And we're done. We showed that we get for free that the union of the AIs is a subset of R, because we're given that they're all intervals on the real line. We just proved that R is a subset of the union of the AIs. And that is the end of the proof.